So let's start with the variants, right? So variants in transportation problem. Right, so we are going to see 5 variants. The first is unbalanced transportation problem. Unbalanced transportation problem. Then we are going to deal with the maximization problem. Right, up till now in transportation problem, we were dealing with the minimization aspect, right? Minimization of the total transportation cost. But what if the problem given is of the maximization problem? So how to handle that? No, that also we are going to see. So no, there is one more variation that I'll be telling you when we are going to solve the numerical, that is different production cost, right? We have one more variation, that is no allocation in a particular cell or cells. So that also we are going to see. And lastly, we are going to see the variation in which we are going to deal with the overtime production. As of this lecture is considered, we are going to see unbalanced transportation problem. Now, what is a balanced transportation problem? A balanced transportation problem is a transportation problem in which demand is equal to supply. Similarly, I can say in unbalanced transportation problem, what will happen? My demand is not equal to supply, right? So that means I can say that the summation of all the demands for all these sources is not equal to it is not equal to the summation of all the demands of all the destination centers. So what is this? It is the mathematical representation of demand and supply which are not equal. So this is related with the demand. So the addition of summation of all the demands of summation of all the supplies of all these sources is not equal to the summation of all the demands of all the destination centers, right? So that is, demand is not equal to supply, and that is called as the balanced transportation problem. So what we have to do here is that we have to convert the balanced transportation problem in unbalanced transportation problem into a balanced transportation problem, and then we are going to solve ahead, right? So here what we are going to do is we are going to make a demand is equal to supply, and then we are going to solve it. So how we are going to deal with this? Now let's see that if total supply exceeds the demand, if this is the case, right? It can be anything, right? If demand is not equal to supply, it can be like demand can be on the higher side or supply can be on the higher side. Now let's see that if the supply is on the higher side, so if the total supply exceeds the demand or is more than the demand, so what we are going to do is we are going to consider dummy or fictitious destination which is going to handle excess supply, right? So what is here? If the total supply is more, right? So if the supply is more, what we are going to do, we are going to consider a dummy or a fictitious destination which is going to handle only the excess supply. So what is the excess supply here? It will be supply minus demand will be the value of the excess supply. So we are going to say it with the help of the numerical, but as of now just remember, if the total supply exceeds the demand, so we'll have to handle it by adding a dummy or a fictitious destination which is going to handle this excess supply, and vice versa. If there is total demand exceeds the supply, what will be the case? here consider a dummy or fictitious. Here we don't have to consider a dummy or a fictitious destination. Here we'll have to consider a dummy or a fictitious source which is going to handle excess demand, right? So here again, very important, here demand is exceeding. So what we are going to consider is the dummy or a fictitious source which is going to handle the excess of the demand, right? So no, in the first case here, if you see, if I'm saying that here in this case, if you have to make a difference, so it is here is supply is greater than demand, right? And in this particular case, what I can write is demand is greater than that of the supply, right? So no, these are the two things that we are going to do, and by doing this thing, what we are going to do is now what will happen next is, if we do so, our demand will be equal to supply, and hence it will be a balanced transportation problem, and we can move ahead with the regular regular procedure of solving the transportation problem. Just there is a change in the only there is a change in only one step, right? So let's see it via numerical, and we'll be understanding this in the more detailed fashion, right? So I'm having I'll be writing the numerical in the short. I'm having 4 factories, right, which are A, comma B, comma C, and D, right? The unit they have given us the okay. This is a different sort of numerical we are going to see. We have been given unit production cost, right, of rupees 2, rupees 3, rupees 1, and rupees 5 respectively, right? Production capacity of A is 50 units, for B is it is 70 units, for C is 30 units, and for D is 50 units. There are 4 stores for which the supply is made. So 4 stores which are 1, 2, 3, and 4, and their demands are 25, 35, 105, and 20 units, right? And 20 units. So I'll be writing it here, and 20 units respectively, right? So transportation matrix has been given to us. Transportation matrix is given, and what we have to do is minimize total production and transportation cost. Here it is a different thing that we are handling. So here we have to minimize the total production and transportation cost. The the transportation matrix that has been given is like this: 4 sources and 4 right. So it is A, B, C, D, 1, 2, 3, 4. Right. So these are the factories, or what we can say, and these are the stores. Right. So 2, 4, 6, 11, 10, 8, 7, 5, 13, 3, 9, and 12. 4, 6, 8, and 3 are the transportation matrix that has been given. So here what let's repeat the statement given 4 factories which are A, B, C, D. The unit production cost is given, right? So if they have to produce 1 unit for factory A require 2 rupees, factory B require 3 rupees, factory C require 1 rupees, and factory D require 5 rupees. Production capacity of each of these factories are given. The demands of each of these 4 stores are also given. Transportation matrix is given, and we have to minimize the total production and the transportation cost. Transportation matrix is given. So let's frame out the transportation problem. But yeah, there will be a different consideration that we'll have to do. We require firstly the problems where minimization of the transportation cost, but it is production plus transportation cost. So we have to change our this what has been given here is the transportation matrix. We'll have to construct a production plus transportation matrix, right? So framing the initial solution or framing the transportation problem in this as in this only we are going to complete that step, or because otherwise it will be again a different task at the end. So now what we can do is we can write A, B, C, D here, right? It is 1, 2, 3, 4. So now for factory A, the production cost has been given to us as what? The production cost is 2 rupees. For factory 1 it is 3. For factory C it is 1, and for factory 4 factory D it is 5. So what we are going to do, we are going to add rupees 2. We are going to add, these are the transportation costs, right? And we are going to add the production cost into it. So for factory A, the production plus transportation cost will be 2 plus 2, that is equal to 4. So we'll be adding 2 to this row. We are going to add 3 to this row. We are going to add 1 to this row, and we are going to add 5 to this row. So that will be we'll be getting a production plus transportation matrix here, right? So 4 plus 2 will be equal to 6. 6 plus 2 8 11 plus 2 will be equal to 13, right? Similarly, it will be for this it will be 10 plus 3 13, 8 plus 3 11, 7 plus 3 10, 5 plus 3 is equal to 8. For this, it will be 13 plus 1 is equal to 14, 3 plus 1 is equal to 4, 9 plus 1 is equal to 10, 12 plus 1 is equal to 13. And lastly, we have 4 plus 5 is equal to 9, 6 plus 5 is equal to 11, 8 plus 5 is equal to 13, and 5 plus 3 is equal to 8. So this is the this is the production plus transportation matrix that we have got, and now we can minimize this particular matrix so that we get we get minimization of the total production and the transportation cost. So here we can write here we are framing this problem, so we are going to write the supply and demand as well. So what is the supply of these factories? So it is 50, 70, 30 and 50 again, and the demand has been given as 25, 35, 105 and 20 here, right? So let's check whether it is a balanced transportation problem or not. So what we are going to write here, supply is equal to how much? Supply is the addition of like 50 plus 70 is 120, plus 30 is 150, and plus 50 is 200. So your supply is equal to 200 units, and the demand that we have is how much? Demand is 25 plus 35 plus 105 plus 20. So it comes out to be 165 plus 20 is 185 units, right? So here you can see here the supply is greater than the demand, hence unbalanced transportation problem. Convert to balanced transportation problem by, now what we are going to do here, supply is exceeding the demand. So if supply is exceeding the demand, what we are going to do is refer your previous pages. If we are going to have supply more, so we are going to consider a fictitious destination center. So by considering a fictitious fictitious, we can say here a fictitious store having demand of how much? Having the demand of 200 minus 185 of 200 minus 185 units, that is 15 units. All right, so that is 15 units. So we can reconstruct this particular matrix again, and we can solve by using the we can find out the initial basic feasible solution. Now I will be directly writing here the matrix that will be formed. So there will be now 5 destination centers, and the factories will remain same, right? So it is A, B, C, D, 1, 2, 3, 4. I'll be writing D here, right? So we have considered, so that instead of writing 5, we can write a different figure here. That is the 4, 6, 8, 13. Nextly we have 13, 11, 10 and 8. So 14, 4, 10 and 13, and 9, 11, 13 and 8, right? So what will be the values here? So here we are going to consider the values as 0, right? So for the x's, if I've if I'm having a fictitious store, the values will be 0. If I'm having a fictitious supply, that is fictitious factory, then also will in this particular matrix we are writing the values to be 0 only, right? So supply will be here, demand will be here. Supply, what were the previous supplies that we had? It is 50, 70, 30 and 50. And what will be the demands here? It will be 25, 35, 105, 20, and here it will be, we have already decided it is to be 15 units. So if you do the addition, it comes out to be 200. So here supply is equal to demand is equal to 200. Hence balance transportation problem. Hence proceed. So what should be the next step? Next step should be the finding the initial basic feasible solution. Now all these steps remain same, right? So I'm hoping that you have understood this particular step. Let's solve this problem ahead, right? So finding initial basic feasible solution. I'll be drawing it properly. So we have 4, 6, 8, 13 and 0. We have 13, 11, 10, 8, 0, 14, 4, 10, 13, 0, 9, 11, 13, 8, 0. Okay. So we have 1, 2, 3, 4, 4, and here it is a D. Supply that we have is 50, 70, 30 and 50. Demand that we have is 25, 35, 105, 20 and 50, right? So let's move to with the exam solution. Firstly, what we'll have to do, we'll have to find out the penalties. Let's go with the column first. So it is 9 minus 4, that is penalty is 5. Here we have 4, 6 minus 4, the penalty is 2. Nextly we have 8 and 10. So 10 minus 8 is 2. Nextly we have 8 minus 8 as 0. Lastly the penalty will be 0 here, right? So for first row we have 6 minus 4, that is the penalty is 2. Nextly we have Yeah, the year penalty is 4 minus 0. The penalty here is 4, right? Sorry. Nextly, we have the penalty here as 8 minus 0, that is 8. We have the next penalty that is 0 minus 4, or 4 minus 0, that is 4. And nextly, we have the penalty here is 8 minus 0, that is 8. So if you see the penalties, we have the penalty, highest penalty as 8, and there is a tie. So let's check in which no, where we can do the allocation. So here, if I'm going with this particular penalty, the least cost cell is here, and I can do the allocation of 15 here. And with this particular penalty, the least cost cell is 0, and again I can do 15. So there is again tie, so you can solve this tie arbitrarily. So for me, I'll be doing the allocation here, and now this now becomes a 0, and this particular column get saturated, right? So if I'm doing 15 allocation here, here I'll be having more 35 allocations to do, right? So let's recalculate the penalties again. So this penalty will get cancelled. So let's recalculate the penalty here. Firstly, the column penalties, I guess, will remain same. 9 minus 4 is 5, 6 minus 4 is 2, 10 minus 8 is 2, and 8 minus 8 is 0. For the rows, now they are going to change. So here it will be 6 minus 4, that is equal to 2. Nextly, it will be uh, just a second. It will be 10 minus 8, that will be equal to 2. Nextly, it will be 4, and we have 10 here. So next it will be 6. And lastly, we have penalty 9 minus 8 as 1. Right, let's move ahead, and so maximum penalty that we have is 6 here. So for 6, so the least cost cell is 4, and the maximum allocation that I can do here is 30. So right, so I've done the allocation. This penalty will get cancelled, this row will get cancelled, and here 5 will be remaining, right? So let's recalculate the penalties again. So here 9 minus 4, for column it is 9 minus 4, that is 5. Nextly, it is now 11 minus 6. So the penalty here comes out to be 5, right? Nextly, we have 10 minus 8, that is 2. For the next column, we have 8 minus 8 as 0, right? For the rows now, for first row, we have the penalty as 6 minus 4, that is 2, right? Nextly, we have 10 minus 8, that is 2. Next we have next penalty. For next row, it is already gone, exhausted. For last row, we have the penalty as 9 minus 8, that is equal to 1. Now if we check the penalties, the higher penalty is with column number A, column number 1, and column number 2. So let's check out where we can do the maximum allocation. For this cell, the maximum allocation that is possible is 25, and for here we have this cell, the maximum allocation that is possible is 5. So I'll be doing the allocation here, that is 25, and I'll be exhausting this particular cell here. Here 25 is pending, right? So I can't do no allocation further here. So let's recalculate. This penalty is also gone. Let's recalculate the penalty. 11 minus 6 is 5 again. So here it is 10 minus 8 is 2 again. 8 minus 8 is 0 again. Again for the rows, let's calculate the penalty. It is 8 minus 6, that is 2, that is okay. Nextly, we have the penalty 10 minus 8, that is again 2. And for last row, we have now the penalty will change. It will be 11 minus 8, that will be equal to 11 minus 8, that will be equal to 3, right? So let's do the comparative check of penalties. We have 5 on the higher side, and the least cost cell, that is 6, and here the maximum allocation that we can do is 5 here, and we have done that allocation. So this cell will get exhausted. So here this this column will get exhausted, and here we'll have 20, right? So can we move ahead, right? So we have this row, this column as also exhausted. So let's check the penalties of column number 3. So it is 10 minus 8, that is 2. For column number 4, it is 8 minus 8, that is equal to 0. Right? For column number, for row number 3, for row number 1 now, 13 minus 8, the penalty is 5. Right? So for next, it is 10 minus 8, that is 2. For the last row, it is 13 minus 8, again it is coming out to be 5. So we have a tie in no penalties for 5. So if I consider my first row, the allocation should be done in this particular cell, and the maximum allocation that is possible is 20. Right? In the last row, I will have to do the allocation here, and the maximum allocation that is possible is again, it is again 20 only. Right? So there is again a tie, so I'll be solving this tie by arbitrary allocation. So I'll be doing the allocation here, and this particular row now will be getting exhausted. Right? Other if I've done allocation here 20, so it will be how much here? It will be 85 here. 85 here. So let's recalculate the penalties now. First two columns are already gone. Lastly, we have in third column now the penalty will change. It will be 13 minus 10, that will be equal to 3. In column number 4, the penalty will remain same, that is 8 minus 8 is 0. Right? So for for different, for first row we have already exhausted. For second row, the penalty is 2. 10 minus 8 is 2. And for the last row, the penalty remains same, that is 13 minus 8 is 5. So now the penalty 5 is on the higher side. So the allocation will be done in this particular cell. The maximum allocation that I can do is 20. So this will get exhaust, and this penalty will also get removed. So there will be no allocation that will be possible. So we have only two cells remaining where we need to do the allocation. Right? So firstly, let's do the allocation in this particular cell. So if I'm doing this allocation here, so it will be 0. This penalty will get cancelled. 85 will be remaining. So it will 85 will get converted into 15. Sorry, this here I'll have to update. It is 0 here now, and it was 0. So here it is 15. So the WAM solution that I have got is this. Right? So let's check the number of allocations here. We'll have to go for an optimality check. Right? Here number of allocations is equal to how many? It is 1, 2, 3, 4, 5, 6, 7, and 8. Right? So 8, and m plus n minus 1 value will be 5 plus 4 is 9. 9 minus 1 is 8. So hence we can proceed with optimality check. Right? So I'll be redrawing this for the optimality check. Just a second. Redrawing the WAM solution. So it's A, B, C, D. 1, 2, 3, 4, and it is D here. Right? So 4, 6, 8, 4, 6, 8, 13, 0. We have 25, 5, and 20. 13, 11, 10, 8, 0, and we have 70 here. It is 14, 4, 10, 13, 0, and we have 30 here. And lastly, we have 9, 11, 13, 8, and 0, and we have 15, 20, and 15 here. Right? So this is how we have got the the solution as of now. So we are going to proceed with the UV method. So we are going to find out the values of u1, we are going to find out the value of u2, u3 and u4, right? Similarly, we are going to find out the values of v1, v2, v3, v4 and v5 as well, right? So let's move ahead. For all allocated cells, ui plus vj is equal to cij. So you can write u1 plus v1 is equal to 4, u1 plus v2 is equal to 6, u1 plus v3 is equal to 8. Nextly, we have u2 plus v3 is equal to 10. Mm, sorry, here it is u2, u3 and it is u4. Okay. So for next cell, that is U3, we have U3 plus V2 is equal to 4. Nextly, we have U4 plus V3 is equal to 13. U4 plus V4 is equal to 8. And lastly, U4 plus V5 is equal to 0. So what we are going to do, put V1 is equal to 0. If you put V1 is equal to 0, U1 is equal to 4. V2 is equal to 2. No, V3 will be equal to 8 minus 4, that is equal to 4. Now that we have got V3 value, so U2 value will be equal to 6. We have V2 value as 2, so U3 value is equal to 2. We have V3 value as 4, so U4 value will be 13 minus 4, that is equal to 9. Lastly, we have u4 value as 9, so v4 value will be equal to minus 1. And lastly, u4 is 9, right? So v5 will be equal to minus 9, right? So let's put all these values here. We have a space constraint. Let's see. So u1 is equal to 4. No, v2 is equal to 2. v1 is equal to 0. v3 is equal to 4. u2 is equal to 6. u3 is equal to 2. u4 is equal to 9. v4 is equal to minus 1 and v5 is equal to minus 9. So for all unallocated cells, right, Pij is equal to Pij is equal to Cij minus ui plus vj. So you can do the calculations. Let's list down the all unallocated cells now first. So it is P14, PA4 and PAD. Right. Nextly we have PB1, PB2, PB4 and PBD. Next we have PC1, PC3, PC4 and PCD. And lastly we have PD1, PD2. So let's find out for PA4. It is 4 plus 0, that is 4, and 4 minus 4 comes out to be 0. For PAD, we'll be recalculating. For PA4, it will be 4 minus 1 is 3 and 13 minus 3 is 10. For PAD, it will be 4 minus 9 is minus 5 and 0 plus 5 is 5. For PB1, it is 6 plus 0 is 6 and 13 minus 6 is 7. For PB2, it is 6 plus 2 is 8 and 11 minus 8 is 3. For PB4, it is 6 minus 1, that is 5, and 8 minus 5 is 3. For PBD, it is 6 minus 9 is minus 3, and 0 plus 3 is 3. For PC1, it is 2 plus 0, that is 2, and 14 minus 2 is 12. For PC3, it is 2 plus 4 is 6, and 10 minus 6 is 4. For PC4 is 2 minus 1 is 2 minus 1 is 1 and 13 minus 1 is 12. For PCD, it is 2 minus 9 is minus 7 and 0 plus 7 is 7. For PD1, it is 9 plus 0 is 9 and 9 minus 9 is 0. And for PD2, it is 9 plus 2 is 11 and 11 minus 11 is 0. So we are lucky. We got all the, all the cell evaluations are positive. So the obtained solution is only the optimal solution. So here I can write all cell evaluations are positive, hence obtained solution is optimal. So what we are interested in, total production plus transportation cost, that we have to find out. So that we can do writing by writing 4 into 25 plus 6 into 5 plus 8 into 20 plus 10 into 70 plus 4 into 30 plus 13 into 15 plus 8 into 20 plus 0 into 15. So if you do all this additions, I've done so, and I'm getting the value as rupees 1465.